All right, welcome back. Today we're going to be discussing Lesson 9.1, Special Right Triangles. So we have two special right triangles. We have 45, 45, 90 and a 30, 60, 90 triangle over here. Okay, so this in particular is what we call an isosceles right triangle. Why is this an isosceles right triangle? Well, one, we see that square. That means it's a right angle. And two, it's isosceles because we have two segments that are congruent to each other. So we have a 45 degrees, and 90 degrees. So remember, we talked about, back in the fall semester, the converse of the isosceles triangle theorem, where if you have two angles that are congruent to each other, then the sides opposite to them are congruent. So 45, this creates A, 45, that creates A, and notice that A and A are congruent to each other. So this is a 45, 45, 90. Over here, this is a 30, 60, 90 triangle. This is what we call a scalene right triangle. And why is this scalene? Because none of the sides are congruent, right? None of the sides are congruent, so therefore it's scalene. But it's a right triangle because we can see that square that indicates that it's 90 degrees. So scalene right triangle. Now, what's so special about these triangles? They're called special right triangles because if we know if it's a 30, 60, 90 or a 45, 45, 90, this will help us calculate sides a lot easier because we have these formulas given to us, okay? So with a 45, 45, 90, we have A root 2, okay? So if you have the legs of this type of triangle, you have A and A. But across from the 90-degree angle, the hypotenuse over here is A root 2. This all applies to the 45, 45, 90. Over here, this is a 30, 60, 90, where the legs are A and A root 3, and the hypotenuse is just 2A. So keep this formula, or keep these formulas in mind, because now what I'm going to do is I'm going to show you a picture proof for each of these, triangles here. Picture proof. And I'm just going to be looking at the isosceles right triangle for now. So suppose you have an isosceles right triangle. That is not a right triangle, that's a square. So here's my isosceles right triangle. And we know that this here is perpendicular to that. So it's 90 degrees, okay? So again, this is an isosceles right triangle. That means that this segment here and this segment here are congruent. And if those two segments are congruent, then those angles must be congruent to each other. Okay, so the sum of the interior angles of a triangle is 180. So if I know that this is 90, then this has to be 45 plus 45, right? Because those angles add up to 180 degrees, okay? So this side here is going to be called, our unknown. I'm going to call that A. So if this here is A, then that means this here has to be A. But the question here is, what is this side here? Well, this is a right triangle. So that means I'm going to apply the Pythagorean theorem. So a squared plus b squared equals c squared. So I'm going to call this A, and I'm going to call this B. So basically I'm going to plug it in. So I have a squared plus, this is my B, that's another a squared, equals my c squared, which I don't even know. I'm going to call this, just c. Okay, I'm going to just call that c. So c squared. Now, a squared plus a squared, I have two a squares there, so I'm just going to combine the like terms. So we have two a squares, and that's equal to my c squared. Now, I'm solving for c, so I have to take the square root on both sides. So, if I were to look at this, this is basically 2 times a times a. And since I have a pair of the same a's, that means I'm taking the square root of, a squared over here. That means that a is going to go outside. So a root, what's left over, that 2. So that 2 is going to remain inside of the square root. So basically, this is what C is. C is a root 2. So this formula here, or what I've drawn, matches exactly what we have, from the beginning. So that is the 45, 45, 90 triangle. Okay, so now what I want to go ahead and do is I'm going to prove the 30, 60, 90 triangle. So what I'm going to do is I'm going to draw my 30, 60, 90 triangle. So we have 30, 60, and then this angle here is 90 degrees because this segment is perpendicular to that segment, so they intersect at 90 degrees. And I'm just going to put A here, because since this is the smallest angle, A is going to be my smallest side, okay? Now, what I'm going to do is I'm going to take this triangle and I'm essentially going to reflect that, just like this, with some dashes. So it should be essentially a copy of this triangle over here. So, since I'm copying this triangle, we can see that, okay, if this segment here is 90 degrees, then that means that this segment is 90 as well. And if this angle here is 60 degrees, that means that this angle here is 60 as well. And since this is 30, that means that this here is 30. So I'm going to put 30 there, okay? And one more thing. This side is A. That means that this side here is A. So, what else do we see? Well, this triangle is actually equal angular due to the fact that we have 60 here, 60 here, and if I add these two angles up, that's going to give me 60 here as well, okay? I'm actually going to put 60 right here, so that's 60 degrees. So we have an equal angular triangle. Now keep that in mind that we're dealing with an equal angular triangle. So let's, think of this as one triangle altogether, just for now. So if I add up all these sides here, because again, we're thinking about this triangle as one, particular figure, then that means that A plus A is 2A. So this is 2A. So this side here is 2A. And since, again, we're dealing with an equal angular triangle, that means that the sides must be the same. Equal angular means equilateral. All the sides are the same. So this is 2A, this has to be 2A. And then this here has to be 2A. Okay? So we have 2A here, 2A here, 2A here. But what I'm trying to do is I'm trying to match what we had at the beginning. We have the A component, and then we have the 2A component, as you can see over here. But I need that, I need this side here. So now what I'm going to do is I'm going to stop focusing on this equal angular, equilateral triangle and go back to what I drew at the beginning. So I'm basically focusing on this particular triangle now. Okay? So as you can see, we have my 30, 60, 90 triangle. We have that A over here, and then we have 2A over there. So what is this side? So just like what we did before, we're going to apply the Pythagorean theorem. Why? Because this is a right triangle. So that means we're going to apply the Pythagorean theorem. So A squared plus B squared is equal to C squared. I'm going to call this A, and this is going to be my B. I don't know what B is, but we know for sure that this is my C because it's across from the 90-degree angle. So A squared plus B squared is equal to, this is my C, so it's actually 2A, the quantity squared. So this, I can go ahead and distribute the 2, the exponent of 2, to each of the numbers that you see inside the parentheses. And yes, I'm counting a as a number. That's a variable, right? So that's going to give me a squared plus b squared equals 4a squared. Okay? So now I'm going to subtract, because I need to get b squared by itself, right? I'm going to subtract both sides by a squared. So this will go away, and on the left-hand side of the equation, that's going to give me b squared, which is equal to 4a squared minus an a squared. So it's 4a squared minus 1a squared. That's 3a squared. Okay? So if I were to take the square root on both sides, you get b equals, okay, so this is 3 times a times a. So then if you notice that pair, because a times a is a squared, and you notice that pair, well, you're going to eliminate one of the a's and then bring the other out. So you have a root, what remains inside, 3. So this side, this b, is a root 3. And this should match up with what we had at the beginning. This is what you call a 30, 60, 90 triangle. Okay? So we have 45, 45, 90, and then we have 30, 60, 90. So now what we're going to do, we're going to be looking at some examples. And this is super important. For every 30, 60, 90, or 45, 45, 90 degree triangles, you must label your figures. Always label when you're approaching these types of problems. Now, the angle measures are not always shown. So let me go ahead and give you an example here. We're going to be finding x for a, okay? Notice that we have 45 degrees over here, and we have this 90 degrees over there. So what does this imply? That means that, okay, if I were to add up all these angles, they should equal to 180 degrees. So this is a 45, 90, and this should be 45. And if you were to put that in your calculator, well, they should add up to 180. So what do we have here? We have a 45, 45, 90 triangle. That means we're going to be using this setup over here. And yes, you'll be getting these, charts for your quizzes and tests. So we have a 45, 45, 90 triangle. So what do we need to do? We're going to label our figure. So across from this 45 degree angle, this side here has to be A, just like this over here. So across from 45, this is A. Across from 45, that is A. And then across from 90, that's A root 2. Keep that in mind. So since this is a 45, 45, 90 triangle, of course, that's isosceles. So here, across from this 45 degree angle, this side here has to be A as well, okay? And then across from this 90 degree angle, this is A root 2, okay? So let's take a look at this. Here's A. This doesn't give me enough information. But if I look at this, we know that A is equal to 6, right? And X is equal to A root 2. So X is equal to A root 2. Well, if we know that A is 6, then X has to be 6 root 2. And that is our answer. Okay? So that is our answer. And I'm just going to throw those tick marks here to indicate that those two segments are congruent. So your answer for A is X equals A root 2. Okay, here is B. Notice that we have 9 root 2 here and 9 root 2 here. What does that mean? That means that these two triangles are congruent, and that means that this is isosceles. So when you're dealing with an isosceles right triangle, that means that this is dealing with a 45, 45, 90 triangle here. Okay, so let's go ahead and label our figure. Across from 45, this has to be A. Across from 45 over here, this has to be A as well. And then lastly, this has to be a root 2. So, if we know that a is 9 root 2, y'all, right? And this is what I'm trying to find, where, currently x is equal to a root 2. Well, if a is 9 root 2, and this is a, I'm just going to plug that in. So I have currently x equals a root 2. So then x is equal to 9 root 2 times root 2. Okay, so I replace this a with 9 root 2, and then this root 2 is right here. So remember, with our radical rules, we multiply the coefficient to the coefficient, and then the radicand to the radicand. So root 2 times root 2 is basically 2, right? So it's 9 times, so root 2 times root 2, that's 9 times 2. So x is equal to 18. Do you see that? And then here's C. Okay, notice that these are congruent to each other because it has the same variable. So this is an isosceles. I cannot spell isosceles. How do you spell isosceles? Right triangle. I don't know why I put a C there. Isosceles. There we go. Isosceles right triangle. So 45 here, 45 here. Across from 45 degrees, this is A. Across from 45 degrees here, that's A. And then lastly, across from 90 degrees, this is a root 2. Okay, so I'm trying to find x here, and this is currently, this is the one with the most information. I have a root 2 equals 12. If I can figure out, so my game plan here is if I can figure out what a is equal to, that's going to allow us to figure out what x is. So 12 equals a root 2. I'm going to get a by itself. I'm going to divide both sides by root 2. So this will cancel. These two things will cancel. And I have 12 over root 2. So 12 over root 2. Okay? But you can't leave that as your answer. A cannot be 12 over root 2 because you have to rationalize the denominator. You need to get rid of the radical in the denominator, and by doing so, you have to multiply the top and bottom by that radical. So I'm rationalizing. So multiply across, root 2 times root 2 is 2, and then 12 times root 2 is just simply 12 root 2. Then you can notice that this will create a fraction where you can simplify that fraction because 12 over 2 is just 6 root 2. So we know that a is equal to 6 root 2. And if a is 6 root 2, what is x equal to? That's an equal to 6 root 2. That's your answer. So x is equal to 6 root 2. Okay, so 30, 60, 90 triangles. Find x and y. Let's take a look at this first example over here. We have a 30, 60, 90 triangle. What I want you to do is I need you to refer back to your notes and then see which one is which. Across from 30 degrees, this is labeled as A. Across from 60 degrees, this is labeled as a root 3. And across from 90 degrees, this is labeled as 2A. So the hypotenuse is always 2A for a 30, 60, 90 triangle. Okay? So let's go back to our example. We have 30, 60, 90, label your figure. Across from 30 degrees, we call that 21. We're going to set 21 equal to A. And then across from 60 degrees, we're going to call that A root 3. And then across from 90 degrees, we're going to call that hypotenuse 2A. Okay? So let's look at what let's take a look at which one has the most information. If I look at this over here, x equals 2a, does that give me enough information? Well, no, because we have two variables. Let's take a look at this one. Y is equal to a root 3. Can I use this one over here? Well, no, because again, we have two variables, and that's not going to help us figure out what the actual value of that side is. And that's the same thing for this hypotenuse. But over here, we have a is equal to 21. Now, if a is equal to 21, that's perfect because we have one variable equals a value, a number. That's what we want. So if a is equal to 21, we can actually plug that in to this. So x is equal to 2 times a currently, which is 2 times 21. So x is equal to 42. And then with y, since we know that y is a root 3, that means that I can replace this a with 21. So y is 21 root 3. And basically, we found x and y. For this one, okay, we have 90, 60, so that means that this angle has to be 30. So what type of triangle is this? This is a 30, 60, 90 triangle. So again, when you have a 30, 60, 90 triangle and you're asked to find, variables, label your figure across from 30 degrees. This here is a, so we're going to set x equals to a, and then across from 60 degrees, we're going to set y equal to a root 3, and then across from 90 degrees, we're going to call this 2a. So look at your figure, look at your labeling. Does this here give me enough information? X equals a. Well, no, because we have two variables. What about this one? Y equals a root 3. No, again, we have a y, and we're equaling that to another variable. And it's just basically a copycat of this one over here. We couldn't work with this one at the beginning when we were doing this problem, right? We had to figure out which variable equals a certain value, okay? But if we look at this figure here, we have 2a equals 10. Well, this does give me enough information. You have 2a equals a 10. You have a variable equals a value. This is perfect. I like this one. Even though it is perfect to work with, it's just we're not there yet. And the reason why we're not there yet for this one is because we have a 2a equals 10. We have a coefficient multiplied by a variable, and that it's equal to a value there. So basically what I'm trying to say is get a by itself. And then that is what we can use to, fill in the rest. So if 2a is equal to 10, I'm going to divide both sides by 2. A is equal to 5, right? So if a is equal to 5, then that means x is equal to 5, and y is equal to 5 root 3, okay? So x is equal to 5, and y is equal to 5 root 3, because the thing that I'm doing is I'm trying to figure out which side has the best information, and if I need to, I'll solve for the variable that I'm looking for and plug everything in. Special right triangles. That's how we do it. Okay, so let's take a look at the last problem for today. We have a 30, 60, 90 triangle, and what I'm going to do is, again, I'm going to label my figure. So across from 30 degrees, this is A. Across from the 60 degree angle, this is A root 3. And then across from the 90 degree angle, this is 2A. Okay? All right, so now what I'm going to do is I'm going to look at each side and figure out which one has the best information. If I look at this one over here, I can't use that. That's x equals a. You have a variable equal a variable. You can't work with that. Over here, we have y equals 2a. Again, we have a variable equals a variable, so you can't work with that. You can't work with this whatsoever. So our best thing to look at is this side here. 12 equals a root 3. And this one's a little weird. So 12 equals a root 3. How do I get a by itself? Well, this is like saying 4 equals 2a, right? And you're going to solve for a by dividing both sides by 2. It's the same thing with this one over here. You want to get a by itself. And so in order for you to do that, you need to divide both sides by root 3. So you have 12 root 3 equals a. But again, mathematicians do not like it when you have a radical in the denominator, so you have to rationalize. So you need to multiply the bottom and the top by root 3. So when you're multiplying across, you have 12 root 3 over root 3 times root 3, which is 3, and that's going to simplify to 4 root 3. So a is 4 root 3. That means that x is equal to 4 root 3. And if a is equal to 4 root 3, that means that y is 2 times 4 root 3. So if there are 2 4 root 3s, that means you have 8 root 3. You're multiplying this by the coefficient, so the answer is 8 root 3. And that's your answer. So, recap. In a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is root 3 times the length of the shorter leg. In a 45, 45, 90 triangle, the length of the hypotenuse is root 2 times the length of the leg, and 45, 45, 90 triangles are isosceles right triangles, where the 30, 60, 90 triangles are scalene.